Let's take a look at the next batch of problems. For questions 15 through 17, we're given the information that the sine of alpha is equal to 3/5, where alpha is between pi over 2 and pi. That puts alpha in quadrant 2. We are also told that the cosine of beta is equal to 12 over 13, where this is a typo, that should be, say, beta is between 0 and pi over 2. It places beta in quadrant 1. And we want to find the values of the cosine of alpha plus beta, the sine of 2 alpha, and the tangent of beta over 2. Now these are all formulas that will be on your formula sheet that you can kind of look up. For example, the cosine of alpha plus beta is cosine alpha times cosine beta minus sine alpha sine beta. The sine of 2 alpha is 2 sine alpha times cosine alpha. And the tangent of beta over 2 is going to be 1 minus the cosine of beta divided by the sine of beta. So in addition to knowing the sine of alpha and the cosine of beta, which is given, we also need the cosine of alpha, and we also need to find the sine of beta. And an easy way to do that is with the Pythagorean identity, that sine squared plus cosine squared equals to 1. From the first piece of information, we can solve for the cosine of alpha. We know that the sine of alpha is 3/5, so it's going to be 3/5 squared plus cosine squared alpha equals to 1. You square the 3/5 to get 9 over 25, subtract that from both sides, and we get that the cosine squared of alpha equals 16 over 25. To get the cosine by itself, we need to take the square root of both sides. Remember, every real number has 2 square roots. Because alpha is in quadrant 2, we know the cosine should be negative there, so it needs to be a negative 4/5 for the value of cosine of alpha. Similarly, we can solve for the value of the sine of beta. The sine squared of beta plus the cosine squared of beta should equal to 1. We know that the cosine of beta is 12/13, so we plug that in. Similarly, you start to work through and you solve for the sine. We get sine squared beta equals 25 over 169. You take the square root of both sides, and because beta is in quadrant 1, the sign should be positive there. Beta is going to be a positive 5/13. Knowing each of those 4 basic values, simply all you have to do is plug them into your formula. We're going to find ultimately that the cosine of alpha plus beta is going to be negative 4/5 times 12/13 minus 3/5 times 5/13, which ends up being negative 63 over 65. The sine of 2 alpha is 2 sine alpha cosine alpha. That's going to be 2 times 3/5 times negative 4/5, which gives us a negative 24 over 25. And the tangent of beta over 2 is 1 minus the cosine of beta divided by the sine of beta. That is 1 minus 12/13 over 5/13, which ends up being 1/13 divided by 5/13, which is 1/5.